Okay, what we're going to look at today is solve by factoring. And we've done factoring. Let's say that I've got the quadratic of x squared plus 3x minus 10. All right, and if I asked you to factor that, that means I'm wanting the factors of that equation. What can I multiply to get that equation? So we know that we're going to have two binomials, all right? These binomials, they multiply, those are factors. Factors multiply to get the product, which is the answer, all right? So we need to find those two factors, those two binomials, and the way we did that was we used the x, and remember this is a times c. On the bottom we put b, and then in the middle we're dividing by a. So here we need to find the factors. A times c in this case would be negative 10, and b is positive 3. So I'm looking for the factors of negative 10 that add up to 3. So what factors of negative 10? So you've got negative 10 and 1, or 10 and negative 1. Then you've got 2 and negative 5, or negative 2 and 5. And that's it. That's all your factors. So you're looking for the ones, if I added those numbers, these pairs, these factors, if I added them together, which one would give me positive 3? Well, negative 2 plus 5 is positive 3. So we're going to use that set of factors. Okay? All right, so a, in this case, the coefficient of x squared is a, and a is 1, so we're going to divide each of these by 1. 5 divided by 1 is 5, and negative 2 divided by 1 is negative 2. So we put our x in front of the binomials, at the front of the binomials, so that's how we're going to get x squared. And then we're going to put our factors, negative 2 and positive 5. Okay? So that's just a review on factoring. And what we're going to do today is take these factors and find the solution. Okay? And what you're going to do is you're going to take the factors and you're going to set them to 0. So x minus 2 equals 0, and x plus 5 equals 0. All right? So anytime we have an x in an equation, we're going to solve for x if we can, and we can. We get rid of negative 2 by adding 2, so x equals 0 plus 2 is 2. So there's one solution, and then I'm going to move the 5 to the other side by subtracting, so x equals negative 5. So there's your other solution. All right, your solutions are going to be the opposite of your factors when it's just a single number. Okay? So if you notice here your factor was negative 2, your solution's 2. Here your factor was 5, your solution's negative 5. And that works when we have just that single step. Okay? Let's look at these. All right, this one we just did, okay? So let's try number 1 here. All right, so we need to do our x, and we're going to, a is 1, b is 4, c is 3. So a times c, 1 times 3 is 3, and b is 4, and we're dividing by a, which is 1. So the factors of 3 that add up to 4. Well, the only factors of 3 are 3 and 1. 3 plus 1 is 4, and 3 times 1 is 3. Remember, always test. You multiply them to get that, and you add them to get that, okay? Make sure you do that, because sometimes something looks like it's right, but you go too quick without checking it. All right, so my binomials would be x plus 3 and x plus 1. All right, so what you're going to do is set them to 0. So x equals negative 3. And then this one, set it to 0. So x equals negative 1. Okay. Remember, you move something to the other side by doing the opposite operation. All right, let's look at this one. All right, a is 1, b is 1, c is negative 2. So a times c, negative 2. b is 1, and we're dividing by 1. All right, so factors of negative 2 that add up to 1. Well, I would say 2 times negative 1 is negative 2. 2 plus negative 1 is 1. So those are our factors. So my binomials are x plus 2 and x minus 1. Set it to 0. So x equals negative 2. Set it to 0. X equals 1. All right. And again, when it's just a single number like this, it's not a fraction, then your solution is going to be the opposite of these. You got 2 and negative 1 over here. Here, your solutions are negative 2 and 1. All right, let's go down to number 7. 1 times 25 is 25, and then b is 10, and we're dividing by 1. So factors of 25 that add up to 10, well, that would be 5 and 5. 5 times 5 is 25. 5 plus 5 is 10. All right? So your factor is 5. X plus 5 times x plus 5 will give you that. Remember, as a refresher or review, remember if you distribute, x times x is x squared. X times 5 is 5x. Then 5x will be 10x. And 5 times 5 is 25. Okay? Just a refresher there. All right, so we're going to set these to 0. X plus 5 equals 0. So x is negative 5. And since this is the same thing, we could have written it as x plus 5 squared. Then you know you're going to have the same thing, right? So we're only going to have one solution. So x equals negative 5. Okay. All right, let's go to the other page. Let's look at one of these. Okay. What do you notice about this one? The others, we didn't have any, but we should also always be looking to see if there's a common factor. And there is, so I'm going to take that out first. And you're going to get x minus 2. All right? Well, if I set this to 0, and I set x minus 2 equals 0, then I get x equals, you're going to divide by 6, so 0, and then I'm going to add 2, x equals 2. All right, even though I didn't do the tree, I didn't have to factor it out, I just factored out my GCF, and I set both of these to 0 and solved. So my solutions were 0 and 2. Okay, let's look at this one. All right, again, we've got a common factor of the variable. They both have 1x, right? So x squared divided by x is x, and minus 8x divided by x is 8. So I'm going to set these both to 0. X equals 0 and x equals positive 8. So my solutions are 0 and 8. Okay. Does this one ring a bell? Does something about that look familiar? It's subtracting, so it's differences, right? Difference of x squared and 64. 64 is a perfect square, isn't it? And x squared is a perfect square. So this is one of those difference of squares where we don't have to do the tree. We can just automatically write our factors, right? Be x plus 8 and x minus 8. And remember, that's only if that's a minus sign. Okay, now let's just say that you did not remember difference of square, right? Well, A would be 1. B, there's not a B, so B is 0, and C is negative 64. So you would be doing negative 64 over 0. Factors of negative 64 that add up to 0. Well, that would be negative 8 and 8, right? So we have x plus 8 and x minus 8. So we're going to set those to 0. So 8x equals negative 8, and then x minus 8 equals 0, x equals positive 8. Okay. So yeah, just remember, if you remember difference, subtracting perfect squares, you can take a shortcut. You don't have to do all of this work. All right, this, you should notice that this 4 is a perfect square, 81 is a perfect square, 8x squared is a perfect square, and it's subtracting. So square root of 4x squared is 2x. And we're going to do 1 plus and 1 minus. And square root of 81 is 9. So set these to 0. You're going to have 2x equals negative 9. And so x equals negative 9 over 2, which is negative 4.5. And then if I set 2x minus 9 to 0, I get 2x equals 9, x equals 9 over 2, which is the same thing as positive 4.5. So those are your solutions. All right, let's look at 17. What's different about 17? Well, all of these up here were equal to 0, right? Well, this one's not. So before we can factor, we need it equal to 0. So if I want to make this 0, I would subtract 21, right? So whatever I do on one side, I do on the other. So now we've got x squared plus 4x minus 21 equals 0. All right, so now I can do my x. Factors of negative 21 that add up to 4. Well, 21 would be 1 and 21 and 3 and 7. So if I do a 3 and a 7, 3 times 7 is positive 21. So I need to put a negative with it. So I'm going to put the negative with a 3. And the reason I'm doing it with the 3 is because negative 3 plus 7 is positive 4. If I did it with a 7, I would have ended up with negative 4, and that would not work. So that's, remember, you check your signs. You have to be able to multiply them to get negative 21, add them together to get positive 4. And divided by 1, they stay that way. So it would be x minus 3 and x plus 7. So we're going to set these to 0. So x equals 3. And set that to 0. So x equals negative 7. And again, it's the opposites of these single numbers. Okay. All right. Let's look at 19. I got a 7x over here. Well, I need to subtract 7x and bring it over here and combine my like terms. So x squared minus 12x minus 64 equals 0. Okay. All right, so my a times c is negative 64 and b is negative 12. I didn't have a GCF on that, all right? Whenever you got a 1 in any three numbers, you're not going to have a GCF. All right, so factors of 64. 1 in 64, 2 in 32, 3 won't go, 4 will go 16 times. 4 and 16. I can get 12 out of that, right? I just have to determine which one's going to be a negative. So if I want negative 12, I need to make the 16 a negative. All right, so let's test it. 4 plus negative 16 is negative 12. 4 times negative 16 is negative 64. So both of those work, so we're good. So it's going to be x plus 4, x minus 16. If we set them to 0, so x is negative 4 and x is positive 16. Okay. Let's do one last one. I'm going to take this and put it with this side, okay? So it's positive, so when I bring it over here, if I get rid of it, I have to subtract, right? Subtract, and that'll make 0, won't it? So that'll go away and become 0 equals this. Now, combine your like terms. Do I have like terms? Well, yes, I do. I got x squares there, don't I? I got 1 here and negative 11 there. So 1 plus negative 11 is going to be negative 10. X squared plus 8x. Well, there's nothing else, right? It's basically 0, isn't it? Correct? Okay. Looking at this, do I have a GCF? Well, they both have x, don't they? Right? And both of them can be divided by 2. So we're going to say 2x times, now I'm going to divide each term by 2x, negative 5x plus 4. All right, so we just pulled out a GCF. I can't factor that any further. So it'd be 2x equals 0, divided by 2. 0 divided by 2 is 0. And negative 5x plus 4 equals 0. Negative 5x equals negative 4. So x equals negative divided by negative is positive 4/5. Okay. All right. So it's pretty straightforward. If you didn't have a problem with factoring, then this should be a breeze. If you weren't really 100% confident in factoring, this is great practice. All right. Just remember when you're doing this x, I can't stress it enough times, is when you set your factors down, you say, okay, that's them, check them. Always check them, all right? They need to add together to get the B, multiply together to get your top number, okay? All right, next time we'll look into when A is greater than 1, okay? All right, y'all have a good evening.